the next thing that we are going to see is the obviously LR circuit, which consists of your resistor and your inductor, which is connected in series to an external supply, let's say E. So we know that, so this total EMF, so just if I consider the magnitude, so this is nothing but across the inductor, that is L di by dt, and this one, the voltage drop across the resistor, obviously that is a I into R. Fine, so that is how we can just write it down, the things over here. So E is equals to L di by dt plus I upon R. Now the next thing what we can do for this particular case over here, so you have to just separate those variables. So E minus IR is equals to L di upon dt. Then further I can do one thing, so this E minus IR upon L is equals to di by dt. Fine, okay. So again, the next important thing we can do for this particular case, so just the same thing, just separate those variables. So for this particular case over here, and just try to simplify the things for this particular case in this case. Now just separate those variables. So what we will get for this particular case over here, so this is obviously dt upon L, then this is di upon E minus IR. After that you can just take the integration on both the sides. Yeah, so you have to just take that integration over here. So what you will get, so that is a dt upon L. So this is, we can say 1 by L. So this is your dt 0 to t, and again the next thing obviously we can write it down, di upon E minus IR. Yeah, so di upon E minus IR over here. Fine, so this is again 0 to I. That is how we can write it down. So 1 by L, again this is t, then again you can write it down ln of E minus IR. So since this is again, so minus R, again this is, you can write it down 0 to I over here. Fine, okay. So now you have to just put down those values of that your lower limit and your upper limit. So finally you will get, so again in terms of that I, so I is equals to I naught 1 minus e to the power minus t by tau. So what is that tau? So tau is nothing but L upon R. So that is the constant that we are using over here. So if you see the graph for the same, so obviously it will something, so which is look like that. Yeah, so this is tau is equals to L upon R. So this is a particular value. So for this your time, okay, so this is t is equals to, so that is again what we can consider over here. So at t is equals to tau, that is also one of the special case that you can consider. I is equals to I naught 1 minus e to the power minus t by that, obviously now tau is equals to same, so that will be 1. Yeah, so that will be 63.4%. that is the answer that you will get. So this tau we defined as that constant, that is the L upon R. So this inductor circuit, LR circuit, obviously it will act as a short circuit after a very long time. So the inductor will act as a short circuit, and this is the value of current. So this is the expression for which, with the help of which you can find the value of current at any instant of time. So this is your LR circuit, and the same expression, so that we have written I naught, obviously just remember over here. So that is when the inductor will act as a short circuit. So in case of this resistor and inductor, so this I naught, so when you will get that I naught, obviously after a long time, yeah, in a steady state this will act as a short circuit, and this is your R only, and this is, let's say, some external voltage. So this I naught for this case you can say it is nothing but E upon R, but at a particular time you have to use this expression to get the value for the same over here.